The HTML structure of the code is well organized, starting with a less than doc type HTML declaration, which ensures that the document is recognized as an HTML5 document by browsers. The HTML tag wraps the entire document, and the head and body tags divide the document into two main sections, metadata and content. The head tag includes essential metadata like the charset, UTF-8, the proper text encoding and the viewport meta tag to ensure the page is responsive on various devices. The title element provides a title for the page, displayed on the browser tab. In the body, a form element encapsulates the content, which is a good practice as it groups related input elements and allows for easy data handling if needed. The form includes labels, inputs, and a select drop-down for user interaction. The styling in the code is handled using internal CSS within the style tag. The CSS styles the body, form, headings, labels, and inputs to create a visually appealing and consistent user interface. Background and text color. The body and HTML elements have a dark background color, number 121212, which gives the page a modern, sleek look. The text color, #E0E0E0, is light, creating a high contrast, easily readable interface, which is essential for accessibility. Form styling. The form is styled with a dark background, number 1E1E1E, bordered by a solid line and slightly rounded corners, border radius, 10 px. The box shadow adds a subtle 3D effect, making the form stand out against the background. Input and select elements. Input fields and the drop-down menu, select, are styled uniformly with padding, borders, and background colors that match the overall dark theme. The placeholder text is given a lighter color to distinguish it from user input. The use of box sizing. Border box ensures that the padding and border are included in the element's total width and height, maintaining consistent spacing and layout. The JavaScript in the code is critical for calculating the minimum depth of beams based on user input. The function calculateDepth is the heart of the calculation process. Input handling. The function retrieves user inputs, fee, span, and support condition, using document.getElementById value and converts them to numbers with parsefloat. Condition-based calculation. A switch statement is used to determine the appropriate ratio for calculating depth based on the support condition, for example, simply supported, cantilever. This ratio is a key factor in structural design, affecting how the depth of the beam is calculated. Depth calculation. The depth, min depth, is computed by dividing the span, converted from meters to millimeters, by the selected ratio. If the steel yield strength, Phi, is not the standard 420 megapascals, the depth is adjusted with a multiplier based on the formula, 0.4 plus Phi, 700. Displaying results. The results are dynamically updated on the page using document.getElementByIdResult. Inner text, ensuring that the user receives immediate feedback as they interact with the form. The toFixed2 method ensures that the display depth is rounded to 2 decimal places, which is typical in engineering calculations for clarity and precision. Default calculation on page load. The window.onload function ensures that the calculation is performed immediately when the page loads, providing users with an initial result based on default values. The form is designed to be user-friendly and interactive. As users input different values or select different support conditions, the result updates in real time thanks to the uninput event handler attached to the form. This immediate feedback loop enhances user experience, allowing engineers or designers to experiment with different scenarios and see the results instantly. The use of pre-filled default values in the input fields, for example, span of 10 meters and Phi of 420 megapascals, provides a starting point, reducing the need for users to enter common values repeatedly. The calculation result is presented clearly in a pre-tag, which is appropriate for displaying code like how formatted text. In conclusion, This code snippet is an excellent example of how HTML, CSS, and JavaScript can be combined to create a functional, visually appealing, and user-friendly web application. It effectively serves its purpose as a tool for calculating the minimum depth of non-prestressed beams, with considerations for both technical accuracy and usability.